number of tangents to a circle from any point. What is the meaning of this one? Means based on circle and line only, all this totally whatever chapter is there. Suppose this is the circle with center O. In means circle means inside many infinite number of points are there. These are called interior points. Interior points. Outside also many points will be there to this circle. These are called exterior points. This is important. On circle, on boundary points. These are points on the circle. Points on the circle we use. On the circle. Inside the circle, interior. Inside means interior. Outside means exterior. Boundary. On the circle. Okay? These are the three conditions. Now you see number of tangents to a circle from any point. This is the circle, suppose, with center O. With inside I am drawing one line. You will say that, sir, this line is intersecting the circle at one point only. So can I say tangent? No. Line means what? This is extending this side, this will extend like this also. Will be coming like this. This is becoming. It is intersecting at one more point also. So this is not the tangent. Means suppose this is the point. This is going like this. You will get confusion, sir, it is touching at one point. No. This is the line means with interior point. With interior point of a circle. No tangent can be drawn. This is very point important, can be drawn. Don't get any confusion. No tangent can be drawn with interior point of the circle. Like that. Now suppose this is first point. Second point. This is the circle. On boundary many points are there. Like this. Now suppose this is one line. This line is touching the circle at one point. So this line will become tangent. With boundary point, with the point on the circle, with the point on the circle, only one tangent can be drawn. One tangent. Don't get any confusion. On circle, how many tangents can be drawn? Means infinite number of tangents. On circle, infinite tangents can be drawn. Infinite tangents can be drawn. Why? Because see here, suppose this is the circle, this is the center of the circle. With this point one tangent, with this point one more 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 tangent. On circle infinite number of points are there, so infinite number of tangents can be drawn. But what he is telling here, with the point on a circle, with one point on the circle, how many tangents can be drawn? Only one tangent can be drawn. Don't get any confusion. On circle, how many tangents can be drawn? On the circle, infinite number of tangents can be drawn. But with the boundary point, with one boundary point, how many tangents can be drawn? Means only one tangent. With interior point, only no tangent. With boundary point, one tangent. Next, suppose third point you see. This is the circle. This is the center of the circle. Exterior point, I am taking one point, P. From this point, these are the boundary points. Now you see. Okay. With exterior point, two tangents can be drawn. Don't get any confusion. With interior points, no tangent can be drawn. With the point on the circle, one tangent can be drawn. With the exterior points, two tangents can be drawn. Interior points, exterior points, boundary point. Interior points, no tangent. Boundary points, one tangent. Exterior points, two tangents. These are the number of tangents to a circle from any point. The difference between tangent and length of the tangent. Okay, you will think tangent, length of tangent same. No. Now you see, this is the circle with center O. Tangent, this is the point. This is the point of contact. X, A, Y. Line. X, A, Y. From X to Y or X, Y. This is tangent. Okay. Don't get any confusion. One line. This is the line which is touching the circle at one point, that is tangent. Now, length of tangent. What is the meaning of this one? Length of tangent means what? Means this is the circle. This is the circle with center. This is the tangent. Now what means? The distance from the line segment or line segment, the line segment from the exterior point to the point of contact, the line segment formed with exterior point and point of contact. From X to A, distance from exterior, this is the exterior point. This is point of contact. This is the tangent. The distance from exterior point to the point of contact, the line segment formed with exterior point and point of contact is called length of tangent. Means X to A. This is the line segment. Don't get any confusion. If I draw like this is line. It will be extending. This is not extending. From here it is starting, it is ending here. So this is the line segment. Line segment formed from the point, exterior point to the point of contact. So length of tangent means what? The line segment formed with exterior point and point of contact. This is called length of the tangent from here to here. Suppose from here to here, this is also the point of A Y or Y A. Line segment. Line segment formed from exterior point to the point of contact is called length of the tangent. Don't get any confusion. Tangent is nothing but line. Length of tangent is nothing but line segment. Difference between that is different. Tangent means line. Length of tangent means line segment. This is break. Part of line. Part of line. Part of tangent. What is the formula to find the length of the tangent? Suppose this is the circle with center O. O is the center. Now on boundary one point is there. Exterior one point is there. P. Length of tangent means from exterior point to the boundary point. Distance. Distance between exterior point to the boundary point. Suppose this is, I am taking PT. PT is the length of tangent. Let PT is equal to, I am taking L, length of the tangent. Simply whatever you want. Now from this O, I am joining one radius. OT is the radius. That is equal to R. This is denoted by small r. Okay. Now this from P to O, distance from center to the exterior point, OP. Okay. Let OP is equal to D units be the distance from center to the exterior point. Okay. Now here we know from theorem radius is perpendicular to the tangent. OT is perpendicular to the tangent PT. PT means OTP. Therefore, OTP is a right angled triangle. 90 degrees, this is hypotenuse. This you are taken as D. This is R. Therefore, by Pythagoras theorem, hypotenuse square is equal to side square plus side square. Implies hypotenuse means OP square is equal to side square OT square plus side square PT square. PT square implies here OP D square, OT R square, PT L square implies D square. Bring this minus R square this side is equal to L square. Implies this L square is equal to D square minus R square. L is equal to plus square root you take out this side. Square root of D square minus R square. Therefore, length of the tangent, he will ask in 2 marks, 4 marks like that question. He will give this D distance from center to exterior point. Radius he will give. He will ask to find the length of the tangent. L is equal to square root of d square minus r square. This is theorem number 9.2. Proof is not required. Simply I will explain this one. The length of tangents drawn from external point to a circle are equal. Means one circle is there. See here. This is the circle with center O. Given circle C with center O and radius R. Okay. The length of tangents drawn from an external point. Suppose P. P is the external point. The length of tangents drawn from external point to a circle. Length of tangent. Suppose this is the boundary point T1. Length of tangent. This is one more boundary point. P, suppose Q, R. Now PQ, comma PR are two tangents drawn from P. Don't get any confusion. If you extend this one like this, if you extend like this, PQ is tangent, PR is another tangent. PQ is length of the tangent. Now what we have to show? Length of tangent PQ is equal to length of tangent PR is equal to PR. This we have to prove. So once you keep in your mind, tangents drawn from the external point. How many tangents? Two tangents. PQ, PR. That lengths will be equal. From this to this, if this is 5 centimeters, compulsory this will also become 5 centimeters. Proof simply, you see. Suppose from here to here I am joining the radius. From here to here I am joining the radius. This is 90 degrees. This is also 90 degrees. Means angle Q. Angle Q is equal to angle R is equal to 90 degrees. OQ is equal to OR. Radius. Means radius will be same. This is radius. This is radius. Radius. Radii will be same. Now I am joining P to O. Join PO. PO. PO is equal to PO. Now what means from these two triangles PQO, from triangle PQO comma triangle PRO, you got this angle 90 degrees, this side, same side, this is common side. Now you see this is 90 degrees, means this common side is hypotenuse. Right angle hypotenuse side. Therefore, by right angle hypotenuse side, congruency, triangle PQO is congruent to triangle PRO. The two triangles will become congruent. Therefore, by CPCP, congruent parts of congruence triangles. Another part, corresponding parts, remaining parts. Right angle, this is gone. Hypotenuse, this is gone. Side, this is gone. Now left this. Or this side. This additional sides, this side of this triangle, this side of this triangle. Therefore, what? PQ will be equal to PR. No need of writing the proof. Proof is not required. In exams you will not ask the proof. But what? The length of tangents Tangents means from external point two tangents are drawn. The two tangents value will be same. That much only. Means the length of tangents drawn from external point to a circle are how means equal.